Some people had mentioned that they were struggling a little bit with the limits, so I thought this review might help. I'm going to run through it in 4 different parts. I did post the review already on Google Classroom yesterday. That would have been Thursday, the 10th. So I'm going to just be making these videos periodically and posting them so you can watch it in pieces and try. The evens I will work through with you, and then the odds you can practice on your own. I post the answer key as well. But the biggest thing to remember about limits is that there are definitely different approaches to finding a limit. And your key to success will come from knowing what to do when. And sometimes for some people, that's the hardest thing. So we'll start with graphs and tables. That's going to be our first section. And graphs and tables tend to be the easiest of them, I think. That's me personally. You may feel otherwise because it's real visual. There's really no math involved. You look at it and you ask yourself what appears to be happening around a particular region. Just don't mix up a value with a limit. They're two different things. If you're trying to find a value, it's going to definitely be at the solid point on a graph. If you're going to find a limit, you have to look at not the center, but where it's headed on both sides. And as we look at graphs, I'll talk more about that. When it comes to functions alone without a visual, just the function sort of formula written there, then you're going to have to do some math, mathematically evaluate, and sometimes it's seriously as easy as just plugging in the number and getting it. That's if the function itself is a nice normal continuous function like a parabola or a line. But if it's a piecewise function, then we have to look, you know, at a specific portion maybe. You do have to watch out for the indeterminate form. That's the 0 over 0. I always say that's kind of a red flag that happens. So when we see that, I always think, whoa, 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 something's going on here. Red flag, red flag. That means I can definitely manipulate this. And so then that's going to be another section that we have. But like I said, we'll start with graphs and tables. So on the review, graphs and tables, here's my first set, section 1. Again, we're going to go through the evens together and then the odds you can look at on your own. So you still need to be aware of what you're finding the limit of, obviously, because that's going to determine where you center your direction. And so this is the limit of this function as x approaches 0. And even though direct evaluation or direct substitution could work here or can be done in some of these, you're going to notice that sometimes when you do this, if I plug in the sine of 0 over 0, the sine of 0 over 0, I'm going to get 0 over 0, which is that red flag form. And, uh, and so I would have to do some maybe changing out of a function like replacing sine x with something that it's equivalent to. But if I have a graph, I don't even have to worry about that. It doesn't matter that it came out as the indeterminate form because all I need to do is look at the graph. And I always think where you're finding your limit at, this is approaching 0, I'm going to sort of draw this wall centered at 0. And I want to check where the graph is headed, not at what the value is at 0, because that's a totally different question. I'm not asking what is f of 0. That's not what I'm asking. I'm asking what's the limit as x approaches 0. And so when I'm looking for a limit, remember, you're just looking at where it's headed on each side. Where is the graph going on the left? And so I draw these little arrows. Where's the graph going on the right? I draw the little arrows. The key is, do they meet? Do they come together? I always sort of, if you see me in class teaching this, I make my arms the function and do they come together? And it doesn't have the same effect here. But do they meet on each side? Do they touch on each side? Do those arrows point at each other? Yes, they do. And they point actually at the point 0, comma 1. That's where that center is. Again, that's not a value. There's an open circle there, but that's where they're pointing. They're pointing at that open circle. And so the y is my limit. And so therefore, the limit as x approaches 0 of this function is equal to 1, because that is the y value that these two are pointing at. So it's very visual. And don't confuse, again, values with limits. They're two different things. They can be the same, they can be equal to each other, but they don't have to be. So when I look at the next graph, my value is where this solid dot is. Here, my value, my f of -2 equals this point right here, which is 4. That's where it's a solid dot. But the limit, a totally different question, that's where is the function headed on each side of -2. So again, I always draw this sort of like invisible wall here, and I'm looking at the function. If I could walk along the function on each side of -2, is it pointing on each side of -2 to the same spot? And if it is, that spot that it's pointing to is your limit. So it's pointing at the point -2, comma, -1. The y value is what I'm interested in, and therefore my limit here equals -1. So it's, again, very, very visual. I bring up the whole topic about, or concept about it being visual when you have a graph, because a lot of people see a piecewise function and they sort of freak out a little bit, and we'll talk about how to deal with that when we get into the direct evaluation portion. But as far as when it comes to evaluating a limit with a graph, or finding a limit with a graph, ignore what the function says for the most part. Look at the graph. If you look at number 6, if I don't see a graph with that and I look at number 6, that's kind of a scary looking function. I wouldn't even know where to begin. I might take my graphing calculator out and take a look at that. But thankfully, they graphed it for me. So I have this beautiful graph down here that I can look at. And in this particular problem, what I'm interested in is the limit as x approaches -5. Then there's that little minus there. That means from the left. So I'm looking at only the left-hand side of this function, only from the left. So I don't even care if they come together, because all I care about is the left-hand portion. No interest in the right-hand side. All I'm interested in is the left-hand side. And so I'm going to see where that graph is headed. If I follow that from the left, it follows this little curve. Where is it headed? It's headed to that point. That point is at -5, comma, looks like -2. And so the y value there is my limit, and my limit is -2. Again, it doesn't matter how ugly this function is. All it matters is where this graph is headed, in this case, on the left. Now, if I don't have it set as on the left or on the right, if I'm looking at the function again at -5, then I would try to see, do they meet? And if I were looking at this one, notice how these two things don't come together. And so there, if I was looking for the limit as x approaches -5 in general, I would say that it does not exist, because the limit as x approaches -5 from the left, we found, is -2, but the limit as x approaches -5 on the right is going to a different location. It looks like it's one below, so at -3. These two limits are not the same, therefore the limit as x approaches -5 in general does not exist. You can spell that out. This is a pretty normal shortcut way of writing that, DNE, so you can use that if you'd like. But again, graphically, nice and easy. It gives you a real visual of what you're looking at. So we've got one more, and on the graphs, problem number 8. Number 8 is a situation where we're looking for the limit as x approaches 4, but it doesn't direct me from the left or from the right. It's 4 in general. So I'm going to look at the graph. I'm going to center it at 4, and I'm going to see what's happening on both sides. And I think some of you can see right away that these aren't meeting. Because they're not meeting at a particular location, the left-hand side, I say the limit as x approaches 4 from the left is up here at 1, and the limit as x approaches 4 from the right is down below that, and it looks like it's headed towards 0. Again, I'm coming in on the right hand side. Just even picture, here's my left hand, here's my right hand. This is the left hand side of the graph, this is the right. This is coming from the left, this is coming from the right. A lot of people mix it up like, yeah, but I'm going left. That's not what it's saying. It's saying I'm coming from the right hand side. I'm on the right hand side of the function. And on the right hand side, it looks like it's going to 0. Again, because these two things don't match, we say the limit as x approaches 4 does not exist. Okay? So graphically, again, it's just real visual. Look and see. Check to see, are you coming from the left? Are you coming from the right? If it doesn't specify, then you have to look at both. And they both have to meet in order for there to be a limit. Okay? So let's look at tables. Tables are another one that are visual as well. And our job here, again, we're going to work through the evens. They're asking us to write an appropriate limit statement. So first of all, what are we trying to find the limit of? And then approximate the value. And so again, we have to consider, am I looking from both sides of a number, or am I only looking at a one-sided limit? And so if I look at problem number 10, it looks like I'm a little bit less than -3. These are a little bit less than -3, -3.1. Remember, the bigger the negative, the smaller the value. And over here on the other side of -3, it's a little bit more than -3. And -3 is my sort of center region. Well, they give me the value of -3. This means that f of -3 equals 0, but I am supposed to write a limit statement and then approximate the limit statement. Okay, so this limit that I'm looking at of this function appears to me that it's approaching -3, and it looks like it's approaching -3 on both sides if you look. Then I'll look at my y value. Where does this look like it's headed? Where does this look like it's headed? And when our directions say approximate its value, that's all we can do. I don't know exactly where it's headed, but it looks like it's getting pretty close to 5.5 would be my guess, and that's the best I can do. And if you say give a value that's reasonable, that's all you need. It's just got to be a reasonable value for that limit. Okay, so if my table's a little bit smaller, like problem number 12, a little bit smaller table, then I'm probably looking at a one-sided limit. So I have to look really closely at what's given, because it could be written backwards. I just have to check size-wise what's going on. And so it looks to me like this is the limit as x is approaching -2 of the function, but it's only approaching -2 on one side, and -1.999 is a little bit bigger than -2. Remember, the smaller the negative, the bigger the value. So this one's coming from the right because the values are slightly bigger than -2. If the values were slightly smaller than -2, then I would be coming from the left. And if you kind of peek up at the one above, to the right it's a little bit bigger, to the left it's a little bit smaller, but this one is a two-sided limit. It's coming on both sides. This one, all the numbers are only written on the left, but the size of those numbers is what I'm interested in. So be a little bit careful and a little bit aware. So Again, you don't need to write this, but it's telling me that the value of negative 2 is 10. That's what the value of negative 2 is. But I'm interested in the limit, and the limit is what's happening here. And I don't know, I guess I could say maybe this looks like it's a third. 0.33333 repeating-ish was my guess. What if you just wrote 0.3333? Fine. I can't say I would accept just zero point 0.3 because it's clearly getting bigger than that. Like this is bigger than zero point 0.3. The next one up is even a little bit bigger than 0.3123, a little bit bigger than 0.3233. Sorry. So this is my best approximate. Again, this is just an approximate, and there is a little bit of wiggle room on some of those. So just be aware of that and be careful. All right, so this is section 1 video. Again, evens, give the odds a try, see how you do. I will make the next video shortly and post them, like I said, periodically. And if you have any questions or concerns, feel free to shoot me an email. I will check at least once a day, maybe sometimes more, but I will check regularly through break. So good luck with it. And as always, I really hope to see you guys soon. Have a good one.